Institute of Engineering and Technology.
Hello students, after completion of two main parts of calculus, partial derivative and multiple integration, today we are going to start our third part of the content, which is sequence and series. In this talk particularly, we are focusing on sequence, and then later on we'll see the second part of this chapter, which is infinite series. So the first of all, we need to discuss what do we mean by sequence, and then what do we mean by infinite sequence. In today's talk, we are going to discuss about what do we mean by sequence, what do we mean by infinite sequence, what are different possibilities with the infinite sequence in terms of convergence and divergence, and what will be the bounds of sequence, and what we can say about the nature of sequence in form of its increasing and decreasing nature. So today's talk is all about sequence and some basic definitions. So let us start our first part in this chapter, which is infinite sequence. So in this infinite sequence, first of all, we are going to consider some definition. Let us discuss first of all what do we mean by sequence. If I consider a list of numbers a1, a2 up to so on an, and if these numbers are considered particularly in some specific order, then it is known as sequence. Now we know that what do we mean by this specific order? Means there is some relation in between all these numbers. Like we can consider 30 or 31 days in the month, 7 days in a week. There is a particular order of days in a week, and this order is given by Sunday, Monday, Tuesday, and so on. Likewise, there is a specific order in the months of a year, January, February, March, and so on. And then there is a particular order in the years of a century, like 1901, 1902, 1903 up to so on up to 2000. So that means we are already considering sequence in our daily life. Now suppose I consider a rubber ball, and if I consider that ball at some particular height, say h, and if I leave it, then due to the bouncing property of this ball, after hitting the surface it will bounce back, and then again it will go to the floor, and then again it will bounce back. So throughout in this process you will observe a decrease in height. Now if you consider all these different heights, you will find a pattern in that. So all these numbers which are actually representing height of the bounce of the ball, they are a1, a2, a3 up to so on an. And then after doing some mathematical analysis, you can always consider a relation in between all these numbers. So to do analysis that at what will be the height of the ball after certain jumps, we need to discuss sequence. So this is meaning of sequence. Now what do we mean by infinite sequence? Infinite sequence means a sequence of infinitely many numbers. This will happen in case of, if I consider a ball which is again hitting the floor, and if I consider its jumps, then it is almost near to infinity. Because of some frictional forces, it will come to the rest after certain level, but still there are infinitely many jumps in this sequence. Similarly, if I want to find value of pi, if I want to find value of pi by 3, how I can find that value? For that also we need infinitely many terms in addition or in subtraction. That will be our discussion in series. So sequence is nothing but a fundamental block into the part of infinite series. The next part, which is how to denote all such sequences. So if I consider root 1, root 2, root 3 up to root n, then the sequence is generally denoted by small alphabetic letters a n in curly bracket, and then it is from n equal to 1 to n equal to infinity. Another sequence is 1, 1 by 2, 1 by 3 up to so on 1 by n. Now I am denoting it by bn. We can choose any alphabet, but generally it is in a specific order like A, B, C and so on. Finally, it can be in an alternating form also. So the first two sequences are sequences of positive numbers only, whereas the third sequence is containing of all possible numbers which are coming from the right hand side of the number line as well as from the left hand side. That means they are positive as well as negative. Now let us consider graphical interpretation of sequence. What do we mean by sequence graphically? So I will take two different interpretations to understand this role of sequence in two-dimensional xy plane. The first consideration is I am denoting value of first number, second number and so on directly on the x-axis. So you can see clearly the first number over here is equal to 1, and that is nothing but value of root of 1. And then you can see the number which is near to the first value is somewhere in between 1 and 2. That is nothing but the root of 2. Roughly it is 1.41. And so on, as the value of n is increasing, the number is moving towards the right hand side in the number line. But one thing you should note over here, that in the initial values the gap between two numbers and after certain level the gap between two numbers, if you observe these two particular phenomena, you will see that as the value of n is increasing, the gap between two consecutive values are decreasing. To understand this thing more clearly, let us consider this interpretation. Now in x-axis I am denoting index, and on y-axis I am denoting value of the an, means index n and value an. So you can see clearly, if I take 1 the value is 1, if I take 2 the value is 1.41 something, and so on. I am now denoting values which is in between 1 and 2 also. So if you look carefully, as the value of n is increasing, the height in between two consecutive points are almost similar, means with the negligible increase. So that means now they are coming closer and closer. So keeping these two pictures in our mind, we got some idea about sequence, that there is a possibility that after certain level the values of an, they are coming closer to each other and they are increasing in value. Now let us consider another case. Now in this case, values are coming closer to each other, but now it is moving towards the left hand side. If I take 1 upon n, my first value is 1, second value is 1 by 2, 1 by 3 and so on. So as value of n is increasing, sequence is moving towards 0, you can see clearly, and as it comes closer to 0, it becomes dense. So you can see a cluster of points in the neighborhood of 0. Keep this picture in your mind, and again I am taking the second interpretation, in which I am taking x-axis as index and y-axis as value of an. As value of n is increasing, value of an is decreasing, and after certain level you will see that value of an is reaching that x-axis. That means it is coming closer and closer to 0. So it may happen that your value is coming closer and closer to 0 as value of n is increasing. This is exactly opposite scenario to our previous case. So these two frames will represent that how actually value of n can move towards 0 also as value of n is increasing. Now let us come to the third part. Now see here the values are moving towards origin but now in a different pattern. If I consider this sequence, then the values are coming from left and then coming from right also. Means they are reaching the origin by considering left-handed as well as right-handed values alternatively. As here number 1 by n is multiplied by minus 1 raised to n. So actually it is a series of 1 by n, but now the values are distributed on the both sides of our x-axis. So now what will happen if I take neighborhood of point 0, in the neighborhood from the left and from right I will get infinitely many points, whereas in the previous case the right hand side was with infinitely many points and the left hand side was empty. Now keeping this picture in our mind, let us consider our regular second construction, which is x denote index whereas y denote value of an. Now you can see the pattern over here, the values are jumping from upside down and then it is reaching origin. So now you can see clearly that value 0 is approached from two different ways, from positive y-axis and from negative y-axis also. So this is the different interpretation of sequence. It may happen that your sequence is increasing and moving towards infinity. It may happen that your sequence is increasing and moving towards 0, and it may happen that it is alternative in nature. So this third phenomena gives us idea about alternating nature of sequence. Now coming to the next part, after considering this, whether this increasing or decreasing or alternating sequence will converge somewhere or not. Now what do we mean by converge? Converge means whether there will be enough points or infinitely many points if I consider any particular point in its neighborhood. As we have seen in case of 1 by n, if I take 0, there are infinitely many points in the neighborhood of that point. So we can say that that sequence is converging to 0. So any sequence will converge to a particular number capital L if and only if I consider neighborhood of L, there is a cluster of infinitely many points in that neighborhood. This is the whole idea about convergence. Let us define it with help of this definition, that is sequence AN is convergent to some number capital L if for any positive number epsilon there exists integer n and index small n such that for all small n greater than n, mode of an minus L is less than epsilon. It's quite easy to understand, as it simply means that if you consider any positive number epsilon, this epsilon is nothing but the radius of your neighborhood of point L. So if I consider capital L and if I take neighborhood around that L with radius epsilon, then in that you will find infinitely many points which are actually small n greater than capital N. The notation for this is limit n tends to infinity, an is equal to L, or simply it is written as an tending to L, and L is known as limit of sequence. Now see, as I told you, this is how we are considering this definition graphically. In first picture on your left hand side, you can see clearly that the values are approaching L, and whenever it will enter this neighborhood L minus epsilon to L plus epsilon, there is a cluster of infinitely many points in that neighborhood. And then in the second image, we are seeing our regular interpretation, which is on x-axis I am taking index, on y-axis I am taking a. So initially it may happen that your values are in a haphazard form or they are coming randomly, but after that capital N, your all values will start moving towards L in a certain band, and that band is L minus epsilon to L plus epsilon. So the values will fall inside that particular band. Now let us come to the next part, which is actually the complementary part of convergence, which is known as divergence. So the simple meaning of divergence is, if we cannot find such number capital L for given epsilon, that means our sequence is divergent. Now once we are using the word that sequence is divergence, it will reach infinity or it will reach negative infinity. So the sequence is divergent and it is moving towards infinity if for any positive number m there exists capital N, such that for all index n greater than m, an is greater than m. This simply means that after this capital N, all of your values are greater than a particular height which is denoted by m. So now it will reach to infinity in a positive sense. Now exactly the opposite case would be, if I consider this scenario in the reverse way, then it will reach to negative infinity. To make this thing clear, let me consider first graph which will give you idea about how the divergence is taking place towards infinity. Now if you look at this picture, after certain numbers which is equal to capital N, your values are jumping above this line which is denoted by red line, which is height m. So it will always remain above this and it will go towards infinity. So it is divergence towards infinity. And exactly in the reverse way, if I consider divergence towards negative infinity, your points are dropping down, and once it will reach that limit small m, it will now go towards negative infinity. So it is divergence towards negative infinity. It may happen that initially those points are increasing or decreasing, but after certain values they will start moving towards positive infinity or towards negative infinity. Now let us consider our first case. Now this is how your values will start increasing after certain level. So if I consider a graph of, or if I consider a sequence which is given by e raised to n, and if I take n tends to infinity, you can see clearly it is exponential growth, so it will move rapidly towards infinity after certain level. So it means it is divergence, and this divergence is towards positive infinity. Whenever we are using the words divergence, it is very important to understand whether it is moving towards positive infinity or towards negative infinity. Now let us come to the second part. Now in second part, I am considering, so you can see clearly the values of this sequence is decreasing and it is moving towards infinity as value of n is increasing. So this is how divergence means moving towards negative infinity. So these are two possible cases. In divergence, it may happen that you are moving towards infinity, it may happen that you are moving towards negative infinity. But these are not the only cases. It may happen that your sequence is remaining inside certain values, but still they are fluctuating, and so they are not convergence. And that means now we need to define a phenomena which is known as bounded sequence. Now what do we mean by bounded sequence? If I consider a sequence an, then it is bounded above by capital M if after certain index value and all values of an they remains below or exactly equal to m. This is how we can consider the graphical interpretation of bounded above sequence. See, if I move my point from n equal to 1 to n equal to infinity, my values of a n are increasing initially, and then suddenly they will be stubborn by that value which is given by red line. So that means that red line is the uppermost bound for the given sequence. So your values are not going to increase above this particular bound. So that means this sequence is bounded above sequence. Now let us consider another case which is bounded below sequence. Now it may happen that your sequence initially is decreasing, and then after certain level it will stop decreasing nature and it will move parallel to the x-axis, and then you can then create the bound which is working as a lower bound of the sequence. So these two pictures are making clear what do we mean by bounded below sequence and what do we mean by bounded above sequence. So now again the natural question over here is, if you look at these two pictures, in the first picture I am taking bounded below sequence, and you can see clearly the values are moving very much parallel to that red line, which means ultimately after certain stages those values will create a cluster around that red line, and so it is convergent sequence. The same thing is happening in the bounded above sequence also. But does it mean that boundedness of the sequence will give you guarantee of convergence? Again, it is a topic of moot. So if I consider a bounded sequence, it may happen that it is divergent. This is the case. If I take two bounds, capital M and small n, which are upper and the lower bounds of the sequence, it may happen that your sequence is remaining inside these two boundaries, but yet it is not convergent. That means it is not creating that cluster which was happening in previous discussion. Let us consider one example of this. If my sequence is sine of n, you can see clearly the values are remaining inside those two bounds, but still they are not convergent, means they are not giving any cluster about point. And that means the sequence is bounded above, bounded below, so it is bounded, but it is not convergent. Now we need to add one more feature into this. As we have seen that if our sequence is bounded above, bounded below, yet it may happen that it is not convergent. So what we should add to this particular nature of the sequence so that it will give you guarantee of convergence? So for that we need to discuss monotonic sequence. Now in this monotonic sequence we are going to consider two cases: non-decreasing sequence and non-increasing sequence. What do we mean by non-decreasing sequence? If I consider sequence an, and if an remains less than or equal to an plus 1 for all capital N right from its initial value, that means it is non-decreasing sequence. Similarly, if I consider non-increasing sequence, then an is always greater than or equal to an plus 1. That means if all upcoming values are remaining greater or equal to the previous value, obviously the sequence is known as non-decreasing. Similarly, if the upcoming values are remaining less or equal to the previous value, sequence is non-increasing. Let us consider some examples. If I take 1 by 2, 2 by 3, 3 by 4 and so on, which is n upon n plus 1, that means the sequence is non-decreasing sequence. The previous value 1 by 2 and the upcoming value 2 by 3, if you compare these two, you will see clearly that the upcoming value is comparatively bigger, and that means this gives you non-decreasing sequence. Similarly, in case of non-increasing, the upcoming value is decreasing. Now it may happen that you are considering 3, 3, 3 and so on, and this means your sequence is both non-decreasing and non-increasing. Finally, it may happen that your sequence is not monotonic sequence, means it is neither non-increasing nor non-decreasing. This is oscillating sequence. It is moving from 1 to minus 1, 1 to minus infinitely many times, and that means it is non-monotonic sequence. So I hope this idea of sequence is pretty much clear now. What do we mean by sequence? Why it is a building block of infinite series? What do we mean by convergence and divergence of sequence? What do we mean by bounded sequence? And finally, what is real meaning of increasing, decreasing or monotonic sequence? In next talk, we are going to discuss some basic theorems of sequence. Thank you.
LJ Institute of Engineering and Technology.